Hello and welcome to this R tutorial. So today we're starting a new branch of machine learning, which is reinforcement learning, and that is taking us closer to the field of artificial intelligence because robots and artificial intelligence that comes with it are partly built with reinforcement learning. So to prevent from any disappointment in the next tutorials, we're not going to build any robot, but we will solve a very interesting problem which is called the multi-armed bandit problem. And we are going to solve this problem with the two most popular algorithms for this. These are the upper confidence bound and the Thompson sampling algorithms. So we're going to start today with upper confidence bound. We're going to implement this algorithm in R. And in this first tutorial, we are going to import the dataset and explain what the problem is. That is, we will explain what the multi-armed bandit problem is about. So let's start with the basics. Let's set the right folder as working directory. So let's go to our machine learning AZ folder, then part 6, reinforcement learning, and section 32, upper confidence bound, UCB. All right. And now in this folder, make sure that you have the ads CTR optimization. CTR is for click-through rate. So we are going to try to optimize the click-through rate of different users on an ad that we put on a social network. And therefore, that's the name of our dataset CSV file. So if you have this dataset, you're now ready to click on this More button here and then set as working directory. Good. And now we are going to import the dataset. So as usual, we're going to call our variable for the dataset, and then equals read.csv, here it is, and then in parentheses, we just need to add in quote the name of the dataset. So it's right here, and it is ads underscore CTR underscore optimization. Here we go. And let's not forget the .csv in the end. And now we're ready to import this dataset. So let's do it. Let's select this line and execute. Dataset well imported. So now let's have a look by clicking on dataset right here. Here we go. Okay, so remember in part 3 classification, we dealt with a problem that consisted of classifying and targeting the users on a social network for some car company marketing campaigns. Remember, we had this business client of the social network that put ads on this social network, and then we made these classification models to target the users on the social network most likely to buy this brand new luxury SUV that the car company launched at a very low price. And basically, to prepare this marketing campaign, this car company prepared an ad that they would put on the social network. And what happened is that the Department of Marketing prepared some different versions of this same ad, putting the car on different sceneries. Like, for example, one ad had the car on a beautiful road, and on another version of the ad, the car is on a mountain, and maybe on another version, it's on a beautiful bridge. Well, the Department of Marketing prepared different versions of this same ad that they would put on the social network. But the problem is that they prepared 10 great versions of this same ad. The 10 versions of this ad look great. So they're actually not very sure of which ad to put on the social network. They want to put the ad that will get the maximum clicks, so that most users buy the SUV. And so they need to put the ad that will lead to the best conversion rate. So what this car company did is that they hired us as a data scientist, and they said, okay, I have 10 versions of the ad. We have a limited budget to place the ads on this social network because putting these ads on the social network costs some money. And so this car company would like us data scientists to find the best strategy to quickly find out which version of this ad is the best for the users. That is, which version of the ad will lead us to the highest conversion rate. That's the CTR, that's the click-through rate. We want to find the ad that will get the most clicks. And so now, speaking of this is leading us to the key difference between what we're about to do now and what we've been doing earlier. Because earlier we had a data set with some data containing independent variables and one dependent variable, and then we did some clustering where we had independent variables only, and now things are different. we start with no data. I know we have some data set in front of us, but this is just a data set for simulation, because what happens in real life, and we're going to pretend we're in real life, we're going to pretend that we don't have any data yet. Well, what happens in real life is that we are going to start experimenting with these ads by placing them on a social network, the different versions of the ad, and according to the results we observe, we will change our strategy to place these ads on the social network. So here are the different steps of the process. We have 10 versions of the same ad, 10 versions of this ad trying to sell this cheap luxury SUV. And each time a user of the social network will log into his account, we will place one version of these 10 ads. And that will be a round. Each time a user connects to its account, we will show him one version of the ad, for example ad 3, version 3 of the ad, and we will observe its response. If the user clicks on the ad, we get a reward equals to 1. And if the user doesn't click on the ad, we get a reward equals to 0. And we're going to do this for 10,000 users on this social network. We're going to show the ad to 10,000 users. We're going to observe if the user clicks yes or no on the ad. If the user clicks on the ad, that will give us 1 reward. And if the user doesn't click on the ad, that will give us 0 reward. However, we're not going to show the different versions of the ad to each user at random. There's going to be a specific strategy to do this. And the key thing to understand about reinforcement learning is that this strategy will depend at each round on the previous results we observed at the previous rounds. So for example, when we are at round 10, well, what happens behind the scene is that the algorithm will look at the different results observed during the first 10 rounds, and according to these results, it will decide which version of the ad it will show to the user. That's why reinforcement learning is also called online learning or interactive learning, because the strategy is dynamic. It depends on the observations from the beginning of the experiment up to the present time. And so now what is this data set? This is just some simulation of what is going to happen when we show the ads to the users. In other words, this is what God knows, because we have no idea on which ad each user is going to click on. And that's what this dataset is telling us. It's telling us for each round, that is for each user connecting to its account, on which versions of the ad the user is going to click on. So let's give an example. Let's explain what happens for the 5 first users. So let's take the first round. And according to the simulation, or according to God, this first user of the social network is going to click on the ad if we show him the first version, the 5th version, and the 9th version. And if we show him the 2nd version, the 3rd version, the 4th version, 6th, 7th, 8th, or 10th version, well, this user is not going to click on the ad. So this is what God knows, but as far as we are concerned, we have no idea on which ads this user will click on. So what about the second user? So that's the second round. At the second round, we show another version of the ad, and according to God's truth, the second user will only click on the ad if we show him the 9th version. The third user will never click on the ad, whatever version we display. The fourth user will only click on the 2nd version and the 8th version, and the 5th user will never click on the ad, whatever version we show to him. Alright, so that's the idea of the problem. And so we're going to build 2 algorithms, the UCB algorithm and the Thompson sampling algorithm. And these algorithms will decide at each round here which version of the ad to show to the user. And depending on the reward the ads will get, that is reward equals 1 if the user clicks on the ad, or reward equals 0 if the user doesn't click on the ad, it will decide which ad to show to the user at the next round according to the previous observations. And so we're going to have 10,000 rounds. If we go down here, we can see that we're showing the ad to 10,000 users. And so, of course, the goal of the algorithm is to maximize the total reward, that is the sum of all the different rewards at each round obtained by the different selections of the ads. Okay, so let's do it. Let's start with upper confidence bound, the UCB algorithm. But before we start implementing this algorithm, I would like to show you something. I would like to show you what would happen if we randomly select the versions of the ad at each round. You know, no algorithm, no strategy. Each time a user connects to its account, we are displaying one version of these 10 ads totally at random. So I actually prepared this algorithm. We're not going to implement it together because this algorithm is actually not very relevant. It's just to give you the motivation of what we will implement in the next tutorials. But this algorithm is actually provided in the folder. You see, it's this random selection file. And actually, I prepared it here. That's the algorithm. So as you can see, I call this algorithm random selection. Here, I'm importing the dataset as we just did, so I don't need to execute that again. And in this section, I am implementing the random selection algorithm that just consists of selecting at random one version of the ad at each round, that is, each time a user connects on its social network accounts. So I'm going to execute this section right now. So here it is, well implemented, and we can see the different results of this algorithm. So the most important result is the total reward. That is, this variable is the sum of the different rewards up to the last round. That is up to the 10,000th user. And so what is this total reward? This total reward is 1,242. So what happened is that the random selection algorithm randomly selected each ad at each round. We can actually see the random selections in this ad selected list. So we can clearly see what happened. At round 0 for the first user, the random selection algorithm selected the version number 4. Then at the second round, the version number 4. Then at the third round, the version number 3. Then the fourth round, version number 1. And the fifth round, version number 4. That's the random selections. And so at each round, based on the God's true results, the selection of the ad generated a reward. So at the first round, for the first user connecting on its account, the random selection algorithm selected the ad number 4, and we see a 0 here, which means that this first user doesn't click on this ad, so we get a 0 reward at the first round. Then what about the second selection? 4. Well, we see here at the second round that there is also a 0 for ad number 4, which means that the second user doesn't click on this ad, and therefore we also get a 0 reward. And the total reward that we observe here is actually the sum of all the rewards that it gets, whether it's 0 or 1, at the end of the 10,000 rounds. Alright, so the interesting thing to remember here is that when we randomly select the ads, we get a reward of 1,242. Well, you know, there's this random factor, and so of course if we select that again, we'll get another reward, but it will be very close to this value here. I'm going to do that again, and as you can see, we get 1,232. And I can even do that again. I get 1,246. Again, 1,236. So we always get a total reward close to 1,200. So let's keep this result in our mind, because then we will compare it to the total reward that we get thanks to our more advanced algorithm, which is the upper confidence bound, and then the Thompson sampling algorithm. So 1,200, let's see how UCB and Thompson sampling beat that. And now just a last thing to show you. As for every algorithm we implement in this course, we get the exciting step in the end, which is to visualize the results. Well, in this part, reinforcement learning, the visualization of the results will consist of visualizing a histogram where we see the different selections of the different versions of the ad. So I'm going to show you what happened for our random selection algorithm. Let's do it. Press Command and Control plus Enter to execute. And here we go. Of course, since our algorithm randomly selected the different versions of the ads at each round, well, of course, we get a nearly uniform distribution of the different versions of the ads. The 10 different versions of the ad were selected more or less the same number of times. Alright, so that was just to give you a little extra motivation, and now time to go pro. let's go back to our UCB algorithm and start implementing it. So remember, 1,200 total reward for the random selection algorithm. Let's see how UCB beats that. So we'll find out in the next tutorial, and until